Hi, welcome to the Shuko Math Practice Lab, Learning through Practicing. And today we're going to start a practice set number 1 for the linearizations. So we're going to have two practice set. The first one, the practice set number 1 for the linearization is more mechanical, how to find the linear approximation. Then the second practice, we're going to take a look at the application type of the problem for the linearization problems here. Okay, and so let's go ahead and take a look at what type of the problems we're going to cover at this practice set. Okay, so for this practice set, we're going to do a few problems here, how to find the general linearization functions here. And then the next things here, we're going to take a look how to find a differential. And so how to evaluate the differential for the given x and the dx value. Then we're going to use the linear approximation to find the sum, like the 1.999 to the fourth power. And how can we do it without using the calculator? And amazingly, we find out, when we use the linear approximation, it's pretty close to what the calculator values. That's kind of the amazing part for the linearization. Okay, so now let's go ahead and get started here. Okay, so we want to find the linearizations at functions at A. That means we want to find the linearization when they're close to the value A equal to the -1. Okay, so remember, let's try to write it out here, the formula for the linearization, so we won't forget. So linearization will be the Lx is Fa plus what? F prime A, and what here? X minus H, right? Okay, so now let's go ahead and do it. So f of x here. So what the first things, let's say, hey, let's do the f prime x. So right now we should be very good at the derivative. So this will be 4x cubed plus 6x. And then I plug in the numbers, f of -1. So this is -1. Okay, so this will be the -1 to the fourth power plus 3, the -1 to the second power here. And so this will be what is 1 plus 3, right? So it's a 4. Okay, then we also need to plug in the -1 to the derivative. So it's 4 to the -1 to the third power, and 6 is equal to -1 times -1. So it's -10. So now my functions here will be the Lx, f of A is 4 plus -10, then the x minus A, right? So minus -1. So what is the final answers here? So this is the 4 minus 10, the x plus 1. All right. All right, so now the next one's here. Let's take a look at this one, the sine x. So the same thing, follow the step, we take a look at the f prime x. So what is sine x? Is a cosine x, right? And then we plug in our a value, so it's a pi over 6. So the sine pi over 6 is 30 degrees. 30 degrees is what? It's 1/2. Okay, and then I plug in the pi over 6 to the f prime. So this will be cosine pi over 6. Cosine pi over 6 is 30 to the square root of 3 over 2, right? From the unit circle, square root 3 over 2. Now I can write it. So the Lx is equal to Fa, right? Fa is 1/2 plus the square root of the 3 over 2 and the x minus pi over 6. So like I mentioned, it's very kind of a mechanical type of problem, just always follow the same formulas here. Okay, so now let's take a look at another one. So let's rewrite this one so we will remember, right? So this is f of A plus f prime A and the x minus A here. All right, so the same thing, the f of x square root of x. So we know the square root of x is x to the 1/2, right? Okay, so first things, let's take the derivative. All right, so the derivative here, so this will be 1/2. X to 1/2 minus 1 is negative 1/2. So then it will be the 1 over square root of x, right? Okay, now you put the 4 into your function. So it's the square root of 4, so it's 2. Then you put the 4 into your derivative. So this is 2, this is 4. So what is here? 1/4 is here, right? Okay, so now let's write our linear approximation. Lx equal to what? It's 4, so it's 2 plus 1/4 and x minus 4. Okay, like I mentioned, it's very, very mechanical, so you should be very good at that. Okay, so now like in here, okay, so first let's take a look at the derivative. So this will be 3/4 x. So this will be 3/4 minus 1, right? So 3/4 minus 1, what is here? So this is 3/4 x to the what? Negative 1/4. So it's really is 3/4, and this is x to the 4th powers, right? Not the 4th power, the 4th roots here. Okay, now let's take a look at f of the 16. So that means 16 to the 3/4. I know the 16, you can say is 2 to the 4th to the 3/4. So it's 2 to the 3, so it's 8. Okay, now I plug in here, plug in the 16 to the derivative. So this is 3, so this is 16 to the 1/4 here. So this is 3, and the 16 is 2 to the 4th, right? And 1/4, so it's 3 to the what? 8, right? So these things come out is 2. All right, so now I can write my Lx is pretty easy, right? F of a, so it's a plus f prime, so it's 3a and x minus 16. Okay, so it's pretty straightforward and it's very easy to do. Okay, now I want to find the differential and evaluate this differential by the given value of x and dx here. Okay, so this one is here, it's also is pretty straightforward. Okay, so let's take a look. Y equal to, okay, so this is y equal to the x over 10. Then I will say dy dx exponential will be itself, and then chain rule x over 10, so it's 1/10. Right? So far, so good. All right. So now you can move the dx to the other side. So this will be 110 e to the x over 10 times dx, right? So now this is 1 over, so this is 10. So you plug in what is the x value, what is the dx value, right? So the x is 0, and the dx is what? 0.1, right? So now you know this one's here is 1. So it's 0.1 over 1/10. Okay, so what is the 0.1 over 1/10? Is 1 over 100, right? So it's 0.01. Okay. Okay, so here, let's do this one. So this one is very similar also. So y is equal to cosine pi x here. So that's how do you estimate. So remember we said the dy, you can use the dy to estimate what delta y is here, right? That's what we, the approximation, you can do that. Okay, so let's do this one here. If you take the derivative of both, the dy, dx, both sides, so we know the sine, the cosine is negative sine pi x, and then times what? Times pi here, right? So it's really, you can put it like this way, it's better so you won't get confused. And then the dy will be negative pi sine pi x, and the dx is here, right? So now let's plug in the value we know. So the dx is negative 0.02. Then the x here is 1/3, so this will be pi over 3. All right, so now my values here is this one will be negative pi, then sine pi over 3, then times negative 0.02. So the sine pi over 3, this will be the square root of the 3 over 2 times pi. And this negative become positive, and then 0.02. So now this will be pretty close to what? 0.054, right? If you plug in the value into your calculator, you can see this is 0.054. All right, so this is how do we find the differentials here, because in our next video, we're going to talk about the applications, right, for those differential. How do I use the dy to estimate the delta y's here? Okay, so now this is the another linear applications to estimate, right? So like in here, so imagine if you don't have the calculator, how difficult to do this, right? So now I can use the linear approximation. So this is 1.9999 to the fourth power. So I say, how about I can set f of x equal to the x to the fourth. Okay, and because 1.9999 is very close to what? Close to the 2, right? So that means I'm going to do a linear approximation at the point 2. All right, so we did the first 4 problems, how to find it, right? So we say, okay, so the f prime x is equal to what? 4x cubed, right? Then I plug in the 2. So f of the 2 is 2 to the 4th. So what is that? This is 16th, right? And then the f prime to the 2 is 4 to 2 to the what? Third, so it's 32. So now my Lx is here will be f of a, so it's 16 plus 32 x minus what? Minus 2 here. So now I'm looking for 1.99 here, right? So that's what I'm trying to approximate, the 1.999. So this will be the 16 plus 32, then the 1.999 minus 2. Okay, so now this is 0.0001, right? So this will be 16 minus 0.32 times 0.001. So this will be 0.032. Okay, so now I will get this is 15.968. Okay, so if I use the calculator, so if you want to see how close this one is, so if you put this into a calculator, what you will get? You will get a 15.9680759 something, right? So see here, they are close all the way to the third decimal. So it's really a very good approximation here. Okay, so now let's take a look for this one. See here. This one is e to the negative 0.015. Well, without the calculator, it's really very difficult to find these values, right? So this is 2.7127 to the 0.015 power. How do I do that, right? So now let's see here. How can I use the linear approximation? Okay, so here, let's say f of x, this is e something. So let's choose the function is like ex. And because 0.015 is very close to what value? Very close to 0. So let's choose a equal to 0. That means I want to find a linear approximation at the point A. Okay, so now let's take a look at how do I do this. So we can just do like what we did before. Let's take the derivatives here. Okay, so let's start. So the f prime x, well, this one is very good. We like ex because ex, the derivative still is ex, right? Now let's put the value. So when a equal to 0, so this will be to the e0 is 1. Let's put the f prime 1, f prime 0. So this will be the e0 equal to 1. All right, so we can write our linear approximation. So it's 1 plus 1 times x minus what? X minus zeros, right? Okay, so this will be the x minus 0. Okay, so now, oh, here, so now this is negative. Let's do this. So this is negative. Let's put this function here. So the derivative, this will be negative, all right? So here, this will be 1. So the f prime 1 will be negative 1. So yeah, let's do this way because then we simplify our functions here. Okay, so here, then this will be negative x minus 0. Yeah, it's much better. So in this ways here, this is your x value kind of match here. So you choose the functions. Okay, all right. So now let me rewrite this one a little bit. F prime x, right? So the f prime x will just be negative e to the negative x. Is because the chain rule. And also then this one here, let's erase it, write it better. Okay, so let's erase this ones here, that's it better. So this will be negative e to the negative 0. So still is negative 1. Okay, so now my linear approximation will be 1. Okay, will be 1 minus 1 times x minus 8 here. Okay, so now this one here is a 0.015, will just be 1 minus 1 times 0.015 minus 0, right? So it's 0.985. Okay, now let's put this one into the calculator. So if this is e to the negative 0.015, if you use the calculator, what is the value you're going to have? You're going to have what? 0.98511, what? 112. Hey, look at how close it is. Very close, right? It's close to a 3 decimal point. That's why we know the linear approximation is really a very amazing tools. You find that, it's really get very close to the true value to provide a good estimations there. Okay, that's it for the first video. And our next practice, we're going to see some work problems and how do we practice the word problems there. Okay, nice talk to you and have a good day. Okay, bye.